In lesson 3.1, we're going to look at solving systems of equations by graphing. This is a little bit of review. You've done this in the past, but you want to get everything in slope-intercept form. We want to be in y equals mx plus b form, and then graph the lines. We can have some different scenarios happening when we graph two lines. Many will intersect at a point, which is going to be the solution, and then we'll talk about ones that are the same line and also ones when they're a parallel line and how we answer that. But let's you're not going to have to write down a whole lot other than they show that 2x plus y goes in y-intercept form as y equals negative 2x plus 5. I'm going to actually show the work like you need to be doing, and you will need to use graph paper to find intersection points because sometimes it does cross in between increments on the grid, so you have to, sometimes it's an estimation process. So we have 2x plus y is equal to 5. We're going to subtract 2x from each side. So y equals negative 2x plus 5, which is what they have right here, that one goes to y equals negative 2x plus 5. The second equation, they have x minus y is equal to 1. Now right here they say that it is that. If you go through the process, you subtract x. So negative y is equal to negative x plus 1. And then this is like negative 1, so we're going to divide everything by negative 1. So y is equal to 1x, because that's going to be a positive 1x minus 1, which is what they have right there. So if I graph these two lines, this one here first, y-intercept is 5. Just showing you the lines they graph. So there's the y-intercept of 5. The slope would be negative 2 over 1. So down 2, right 1, down 2, right 1. So you can see that this is that line right there. And you want to use straight edges also. This one over here, the y-intercept is negative 1. So if I'm looking at this one right here, negative 1, slope is 1 over 1, because it's a positive 1 in front of x, so up 1, right 1, up 1, right 1, up 1, right 1. You draw the line. Obviously, you see that these two lines intersect, or they're showing you, they intersect at the point 2, 1. Sometimes it'll be in between units, and you need to estimate it as best you can. In this case, the solution would be 2, 1, which means that x is equal to 2 and y is equal to 1, which would make both equations true, but we estimated the intersection point. Now, classifying them, the one we just did, we got a solution, it's consistent, and it's actually independent. Consistent and independent cross, intersect, and cross at one point. So whatever that would be. Any two lines that intersect at one point we say are consistent and independent. You're going to have to classify these in there. Consistent and independent. Okay? Consistent and dependent is another thing that can happen. That would be the same line. It's going to have an infinite number of solutions. No matter what you tried for x and y would work. Because basically to get the same line, you have the same equation. When you graph, if you have two equations and they're both the same, it would be one line on top of one line. Every single point is shared on that line. So we call that consistent because there is a solution. There's just more than one. It's dependent because it's the same line, same equation. Inconsistent happens when you have parallel lines. And we always say inconsistent, no solution, because they don't intersect. They don't share a point or multiple points. So it's inconsistent. Are parallel lines, and that's going to be when the slopes are the same, different y-intercepts. So intersecting lines here, let's go through the process of solving for y. So x plus 1/2 y is equal to 5. They're showing you what it's equal to, but let me just show you, because you need to do this in your assignment. You're going to subtract x. So now I have 1/2 y is equal to negative x plus 5. Now, when it's a fraction times it, I always multiply by the reciprocal, so I'm going to multiply by 2. So I multiply this side by 2. Notice there was two terms. I put it in parentheses. So it's y equals negative 2x plus 10, which is what they have right here. You multiply by 2 or distribute to both terms then, or multiply every term by 2. The second one, 3y minus 2x is equal to 6. We're going to solve for y. We're going to add 2x. So 3y is equal to 2x plus 6. Now we're going to to divide by 3, divide by 3. So y is equal to 2/3 x plus 6 divided by 3 is 2. And that's what they got right here. They just didn't show the work, and I want you to put the work in there and make sure you know how to do that. If you graph these 2 points, they're showing you the intersection point there of 3, 4, but 2x plus 10. Now, this actually goes off the grid. 10, as you can see, 1, 2, 3, 4, we got up to 6. So 10 is going to be, up here somewhere. Okay, and then you would go down 2, right 1. It'd be negative 2 over 1. So down 2, right 1. Down 2, right 1. And you can see it's going to be this line right here. And you need to draw it straight because you got to find an intersection point. So I would suggest using straight edges. The second one, y-intercept is 2. The y-intercept is right here of 2. My slope is 2/3. So I go up 2, right 3. So up 2, right 3 would be right there. And notice then the intersection point is 3, 4, so that is your solution, which means x equals 3, y equals 4. If you plug them in, they would make both equations true. Okay, and we classify this. There's one intersection point, so it's consistent and independent, and you need to know these. Next one, this one's going to be a same line example. Notice you got 9x minus 6y is equal to 24. So if we're going to solve for y, we're going to subtract 9x. So negative 6y is equal to negative 9x plus 24. We're going to divide by negative 6 every term. So y is equal to negative divided by negative cancels out. Reduce 9 over 6, but leave it as a fraction to be able to graph it. So 9 over 6 would be 3 over 2. So 3/2 x. 24 divided by negative 6 is negative 4. So there's the first one. If we solve the second one, which was 6x minus 4y is equal to 16, we're going to subtract 6x. Negative 4y is equal to negative 6x plus 16. We're going to divide everything by negative 4. We get y equals, negative divided by negative is positive. It's going to be 3/2 x again, and then minus 4. So what I want you to notice when we solve both these, and they showed you up here, that's what that one equals, and that's what that one equals. But I'm showing you the work to do that. If you graph them, you notice they're the same equation. Now, you still have to graph them and show the graph, even if it comes out and you recognize they're the same equation. So negative 4 is your y-intercept. You're going to go up 3, right 2, which would put you there. Up 3, right 2. That's that line. And obviously, the second line is the same equation. It would be right on top of that. So we say this is still consistent, but now it's consistent and dependent because it's the same line. Dependent meaning it's going to have an infinite number of solutions. So you would have to say it's an infinite number of solutions. Same line, same equation leads to that. And it's consistent and dependent. Consistent and dependent if you have same line, same equation. Parallel lines. So let's go through the process like we've done on the last few problems of solving for y. So 3x plus 4y equals 12. We're going to subtract 3x. So 4y is equal to negative 3x plus 12. We're going to divide by 4. So y is negative 3/4 x plus 3, which is what they're showing you right there. Negative 3/4 x plus 3. 6x plus 8y is equal to negative 16. Solve for y, we're going to subtract 6x. So 8y is equal to negative 6x minus 16. We're going to divide by 8. Every term. So we get y is equal to negative 6/8 reduces to negative 3/4. And then negative 16 divided by 8 is going to be negative 2. So here's what we get. Now, if you notice these two equations, I want you to see that the slopes are negative 3/4 in both of them. Slopes are the same. They're not the same equation, though, because our y-intercept is different, which means they're going to be parallel, but you still need to graph them. So negative 3/4 x plus 3, positive 3 is your y-intercept. Down 3, right 4 would be, as you can see, this line that they have graphed for you. And then the second one, negative 2 is your y-intercept, so right there. Down 3, right 4. If you went the other way, you would go up 3, left 4, you'd be right there. And again, noticing that the slopes are the same, different y-intercepts going to cause parallel lines. Those two lines will not intersect. Parallel lines will never intersect, so they don't share any points. So we say there is no solution. So we say no solution, okay, which is what they did right there, and we classify it as inconsistent. Okay, anytime it's no solution, parallel lines, it's inconsistent. Here's just a word problem. Travis and Mann are planning to record their first CD. The initial startup cost is $1,500. Each CD costs $4 to produce. They plan to sell CDs for $10 each. We need to figure out how many CDs must the band sell before they make a profit. So, notice what they do. They let X be the number of CDs. Y is the number of dollars. Always tell what your variables are representing. So, the cost, Y, when they're saying number of dollars, that's the cost of X CDs, and then the income from X CDs. So that's what they're looking at with the Y's here. The cost, it's $4 per CD, so that's $4 times X CDs, plus the startup cost, which is $1,500. So it's 4X plus $1,500. For the income, they're going to sell them for $10 each, so that's why the income is going to be $10 multiplied times by how many CDs you sell, so it's 10x. If you have those two equations, they've graphed them. Now our scales are a little bit different here. We're going in increments of 1,000 up the vertical scale. Basically it's it's actually by 500s up the vertical scale. They only put every other one on, and then on the horizontal scale or horizontal axis, it's going by 50s. Again, every other grid line there is 100 then. So 10x would be that's like 10x plus 0, so the y-intercept is 0. You rise 10, run 1. Okay, so basically if you rise 10, run 1, because you got to look at your scales, if I rise 1,000, well, that's multiplied by 100, then I'd have to run 100, because 1,000 divided by 100 would reduce to 10. So if you rise 1,000, run 100, you can see that's your line right there. Okay, you can see that that's the line they have graphed. For the other one, 4x plus 1,500, here's 1,500, that's the y-intercept. You rise 4, run 1. You rise 4, run 1. So basically, if I rise 4, run 1, notice what they're doing. They're rising, running, so they're rising from 1,500 to 3,500, so they're rising 2,000. Now, what did you multiply 4 by to get 2,000? Well, it would be 500. So they're really running that many. So that's the slope. It would be rising 4, running 1. But again, it's hard to see that when you're looking at that. So, but that would be this line right here. And notice the intersection point is at 250. Actually, you're running 250. So the intersection point is at 250, 2,500. So remember, X is how many CDs? Okay, so they're saying they intersect at 250, 2,500. That's the break-even point. If the band sells fewer than 250, they're going to lose money. So if they don't get to 250, or sell 250, they're going to lose money. Once they get to 250, that's when they're going to start making the profit. And that's the lesson. Make sure you use graph paper when you're doing your assignment to find your intersection points.